our Milky Way, an island universe of stars that is almost 100,000 light years in diameter and several thousand light years thick. But within the Milky Way is the Sun, and we are about 2/3 of the way out from the center, and we look toward the center and see lots and lots of additional stars, but we can't see past the center. So to us, we're inside the forest trying to figure out what the entire forest looks like. And that's no small feat. It's tricky, actually. The universe is not full merely of stars. There are a lot of other objects too. Just below center, for instance, here is a fuzzy spot. What is that? This is where stars are born. It is a stellar nursery, a nebula, and it has a curious red glow. This one, called the Lagoon Nebula, is 4,100 light years from the Earth. It is made mostly of hydrogen gas that's excited by a very hot star near the center. As is typical for star-forming regions such as the Lagoon Nebula, there are a handful of very hot young stars that usually cause this glow that we see from thousands of light years away. The way this glow occurs requires a little bit of an understanding of chemistry. Since the gas in these nebula is mostly hydrogen, when the hot star emits copious amounts of ultraviolet light, the hydrogen atoms, which consist of a single proton and a single electron, lose their electrons, and this is called ionization. So when that happens, the electron is freely moving around in the nebula, and then it does something called recombination, where it combines again with a hydrogen atom, and when it does that, it emits a characteristic red light, and this is what we see here. It's called hydrogen alpha, and this is a very common emission in these nebulae. These objects, in fact, are common throughout all the many different galaxies in the universe. In fact, they are so bright that you can see them in other galaxies from our own. This is a galaxy called Messier 33. It is in the constellation of Triangulum. It is 2.4 million light years away. Yet even at that vast distance, the hydrogen star-forming regions are still very plainly visible. Stoked by powerhouse stars, the light from these regions in these distant galaxies still reaches us across the vast void. Circling back into our own galaxy, we ask the question, in these star-forming regions, what happens to the stars that form there? Since there are so many stars everywhere we look, how come we don't see glowing red hydrogen gas every place that we look? That's an interesting question, but it does have a solution. For one thing, there is a lot of dark nebula, that is, dark dust and gas that blocks our view of more distant objects. Here back at the lagoon, for instance, you can see a very dark line of material moving from about the center down to the lower right. And you'll see various other areas where it appears that there is dark material blocking the view of the brighter cloud behind. And this is actually what is happening. This is exactly what you're seeing. Here is an object that is all dark. This is called the Horsehead Nebula because it appears to look like a horse's head. This nebula is made of dark material, dark dust, and dense gas through which the light can't penetrate from beyond. It's part of a complex known as the Orion Molecular Cloud. Now what do we mean by molecular cloud? Well, in space, hydrogen gas is the most plentiful gas there is. There's a lot of hydrogen atoms that were formed at the very beginning of the Big Bang, and is the most available atom in the entire universe. That said, hydrogen atoms that are loose out in space might combine with each other and form a small molecule of two hydrogen atoms. This diatomic molecule of hydrogen forms the basis of most of these molecular clouds that we see. Perhaps the most famous nebula of all is this one, the Orion Nebula, Messier 42. This object is 1,400 light years away from our planet and is powered by 4 small stars right in the core of that white area in the center of the screen. These 4 stars are arranged in a rough trapezoidal shape, so they're called the trapezium. Go figure. And if you remember, when we talked about the dark nebula, you can actually see it here in the Orion Nebula. If you look just to the left of center, you can see what looks like an overlapping dark cloud that seems to be blocking the bright nebula behind it. And that's exactly right. In fact, the Orion Nebula is something of a blister on a large, dark molecular cloud in that region of space. And as before, the only reason we can see it is because of the hot, young, and bright stars that are causing the gas, mostly hydrogen, to glow in that light of hydrogen alpha, which is red. But you'll notice that the nebula is not just red. It is also bluish green. This is due to other elements that are also in the molecular cloud region and are also excited in the same way that the hydrogen gas is excited by these hot young stars. But the blue that we see in particular is due to something far more simple. This is just reflected starlight, because the Orion Nebula is known as an emission nebula, doing the hydrogen alpha thing that we talked about before, but it's also a reflection nebula, where dust grains in the nebula actually reflect the bright, hot starlight back to our eyes. So it's a real combination thing going on here, emission and reflection. The Orion Nebula isn't the only place where we see these hot young stars causing the gas to glow within the nebula. The reason that it's popular and well known is probably because the Orion Nebula is one of the very closest emission nebulas to us. Then there is this cluster of stars and its associated nebula. This is called the Eagle Nebula. It's also known as Messier 16, and you're probably familiar with it because the Hubble Space Telescope took a picture of the 3 pillars in the center that you can see here. And this became the photo that circulated around the world called the Pillars of Creation. The Eagle Nebula is 7,000 light years from Earth. And you can see the bright stars to the upper right of center in that image. And those are, of course, powering this nebula and causing it to glow in the way that it does in the light of hydrogen alpha, like the others we have seen. Like the Orion Nebula, the Eagle also has these massive structures, the pillars, if you will, and these are actually areas where there are densities of gas and dust that make the background opaque. This means that stars will likely form inside these areas of compressed gas. And these are areas where the gas is collapsing, and this will form eventually perhaps solar systems and more stars, much like the cluster of stars we see in the Eagle now. It is interesting to note that the universe is a very dynamic place. Here, this is the Bubble Nebula. It is a bubble of gas that is 7,100 light years away from Earth and is caused by a hot star that's in the middle, and this hot star excites and blows the material away from it with a very, very powerful stellar wind. As with all star-forming regions, this one too is buried within a molecular cloud. The hot star is one of these young hot stars that formed there. And once this star began to fuse hydrogen into helium, it began to pump out a very powerful stellar wind, as I said. And this stellar wind is what pushed material, the other gases and dust in the cloud, outward from it, creating this bubble. And along the front of this bubble, you can actually see the shape of it because the hot radiation from the star is exciting the gas and causing it too to glow. It really is a dynamic place, and if we watched the bubble over time, we could actually see it grow larger. Eventually, the bubble itself would expand beyond the range of the ionization potential from this star, and it would become dark gas once again. Like the Bubble Nebula, the Crescent Nebula seen here is another one of these objects that is being excited by another star and made to glow. This is a nebula that's not a star-forming region, but the gas is being energized by a very hot star. Sometimes the things that happen in the universe are really stranger than fiction. Imagine this if you can. The star that is responsible for this nebula was a very massive star, and as it was going through its death throes, it started to swell into a red giant star, which is what our sun will do when it runs out of hydrogen eventually. As it did that, the outer layers of the star were so far away from the core of the star that they were no longer gravitationally bound to the star, and once they had some momentum, they could just keep right on going. Not very fast, at only supersonic speeds, but out they went, and the outer layers of the star sloughed off. This outer envelope then was moving away from the star very slowly. After the star shrank down, it became another type of object called a Wolf-Rayet star, and this had a very powerful stellar wind. So what happened was, this amazingly fast stellar wind that was very, very high power, high energy, caught up to this shell out in space, like a shockwave, and actually started to energize it, so to speak, and cause it to glow very brightly, which is why we see it in this particular shape, in this particular way. Let's take a look at some of the other star-forming regions in our galaxy. This is the Omega Nebula. It's a bright nebula in Sagittarius, which is anywhere between 5,000 and 6,000 light-years from the Earth. Curiously, it's also one of the largest star-forming regions in our galaxy. The Omega Nebula is part of a larger cloud of interstellar material that is almost 40 light-years across. This adds up to a fairly sizable region in space. The Omega Nebula would certainly be visible from other galaxies near our own. Yet another star-forming region is this one. This is the Heart Nebula, and it's in the constellation Cassiopeia. It's also in another arm of the galaxy called the Perseus Arm. Current research shows that we have 4 different spiral arms in our galaxy. Among them, we have the Scutum Centaurus Arm, the Sagittarius Arm, the Perseus Arm, where the Heart Nebula is located, and we have the Norma Arm. The arms of the galaxy are named after the constellations within which the primary arm is located from our vantage point in the galaxy. And you may ask, well, where are we located? What arm are we in? Well, the truth is, we're not in any one of those particular arms. We're actually in a place that's known as the Orion Spur. It's a little area that looks like a part of a spiral arm, but it's separate from the rest of the galaxy, and it's a little segment that comes off of the Perseus Arm. You may remember when I mentioned earlier that the Orion Nebula was the closest, or among the closest, star-forming regions to us. The reason that that is true is because the Orion Nebula exists in the Orion Spur where we are. So that's why it seems relatively close. The Heart Nebula is 7,500 light-years away, out in the Perseus Arm, which is the next spiral arm over, except in a galaxy that's 100,000 light-years across, that turns out to be quite a big distance. Here is another object that is also way out in the Perseus Arm, although farther along and farther from us. At a distance of 9,500 light-years lies this wonder. This is the Pac-Man Nebula. Now, it's named the Pac-Man Nebula for the obvious resemblance to the Pac-Man character from the game. But this is another star-forming region in our galaxy, and if you notice, it has all kinds of knots in it. It has dark nebula, it has bright nebula, and it looks like you're looking at clouds photographed at sunset or something. This is typical of these types of regions. There's tremendous detail that you can get from these images. And so this Pac-Man Nebula photo is actually one of my personal favorites. If you recall, when we talked about the Orion Nebula as being both an emission nebula, showing in that red light of hydrogen alpha, and a reflection nebula, where the starlight is reflected off of dust grains and looks predominantly blue, then this nebula will have more meaning to you. This is called the Trifid Nebula, and you can see why it got the name Trifid because of the three lobes, tri. And this object is actually in the constellation of Sagittarius. It's a wonderful summertime object, and it's 5,200 light years away from the Earth. You'll notice down below that it has a predominant red color, and this is the hydrogen alpha emission from those excited hydrogen atoms we talked about earlier. And at the top, it appears blue. This is that reflected starlight from that star you see right there in the center. Now, one of two things can be happening. Either that star isn't hot enough to ionize the hydrogen gas that may very well be in that area, or the star's stellar wind has blown most of that hydrogen gas away with its radiation pressure. And this happens in some of these nebulae, and they literally clear whole areas of space. Remember the Bubble Nebula? It was clearing out that whole area around the star with its very fierce stellar wind. Well, even stars that aren't these very powerful Wolf-Rayet stars, like in the Bubble, can still clear the area around them. You may remember that we talked about these dark nebulae, which obscure the objects behind them to us. Here in the Trifid Nebula, you can actually see those three dark lanes in the red part of the nebula. These are obscuring the bright nebula behind. Well, there are an awful lot of dark nebulae in our galaxy and in other galaxies, so we could never hope to see all of the star-forming regions that our galaxy has to offer just by looking out into space. The reason is because most of these star-forming regions occur in the spiral arms of the galaxy, and unfortunately, so too do the dark nebula appear in these spiral arms and are usually associated with these star-forming regions. So there's a good chance that they will be obscured from our vantage point. But the other has to do with the stars themselves. When stars are formed in stellar nurseries, they're usually young and hot and have a very, very powerful stellar wind. And this stellar wind tends to diffuse and disperse hydrogen gas and any dust that may be in the cloud that they formed within. This means that over time, stellar nurseries will end up dissipating and becoming thinned out and dispersed to the interstellar medium. That is one reason why we don't see stellar nurseries everywhere we look in the sky. The other has to do with the motions of the stars. They're racing through space as they too orbit the galaxy, just as the sun orbits the galaxy. Now our galaxy, as I said, is 100,000 light years across. It takes about 230 plus million years or so for the sun to go around the galaxy once. And actually, as a point of interest, it's done that around 19 times since the formation of the Earth. What happens is that the stars form in these stellar nurseries, and as they move around the galaxy, they are perturbed or disturbed by other stars that they pass by, and this pulls them away from the cloud from within which they formed, and the long-term effect is that the stars will migrate away from their birthplaces. An example, this image here is of the double cluster in the constellation of Perseus. This double cluster is 7,500 light years from us, and there's no hint of a star-forming region. And that's because of any and all of the facts we've just discussed. The star's own motions allowed them to migrate away from the cloud within which they were born, plus the cloud dissipated over time because of these hot young stars, and the stars in the double cluster are very young and very, very hot. And many of them are supergiant stars, so they have powerful stellar winds. When stars begin fusing hydrogen into helium, which is their primary fuel source, nuclear fusion, they do this for trillions of years at the long end and only a few hundred million at the short end. The more massive a star is, the shorter its life will be. So for quite a long time, a star will be, well, boring. It will be fusing hydrogen to helium, and nothing much will be happening. Maybe planets will form around the star, like happened here in our solar system, or maybe a spacefaring civilization could rise and ply the stars at some point in the future. This is all fanciful thinking, but these are real possibilities that could occur. Now at the long end, stars like our Sun last about 10 billion years, and their end is not nearly as traumatic as the more massive stars. The more massive stars tend to end their lives in cataclysmic explosions called supernovae. Here is an example right here. This is called the Crab Nebula, and it's in the constellation of Taurus. It's a supernova remnant that's 6,500 light years from the Earth and didn't exist until 1054 AD, when Chinese astronomers noticed a new star in the sky. When we turned our telescopes to that location later, we saw the Crab Nebula. And over the past 100 years, monitoring it, we could actually see it expanding. Here is another supernova remnant. This one is in the constellation of Cygnus, and it's called the Veil Nebula. It's 1,470 light years from the Earth, which accounts for its fairly large size in our sky. Many of the elements in our periodic table come from supernova explosions. Stars also form elements in their cores throughout their lifetime. These gossamer wisps, with all their delicacy, belie the unfathomable violence that spawned them. The supernova reigns very high on the list of game-changing events that the universe can throw at us. But stars like the Sun end their lives in a more quiescent way. Putting it simply, when stars like our Sun run out of their primary nuclear fuel, they swell into giant, bloated, red stars. This is a very turbulent time for such stars, and as it expands into a red giant, it may slough off its outer layers and expel them. In our Sun's case, it will swallow Mercury, Venus, and even the Earth. When our Sun finally fully exhausts all the remaining nuclear fuel that it has, it will shrink and contract down to a small white dwarf star that's only about the size of the Earth. From another star system, there will be a new nebula in the universe. And this nebula will be surrounding what used to be our Sun. These nebulae are called planetary nebulae, so called for their tendency to look like small, round, fuzzy objects that could be mistaken for planets. And they're the remains of stars that have shed their outer layers. This is the Ring Nebula in the constellation of Lyra. If you look carefully, in the middle, you can see a tiny white star. That little tiny star is a white dwarf, which is a star that's in the end stage of its life. Bereft of its outer layers, the star is now just a little hot core, and it sits there and cools slowly over millions of years until it becomes what's known as a black dwarf. And then the nebula will no longer shine because the glow is caused by the hot ultraviolet radiation coming from that white dwarf in the center. Not all planetary nebulae look like round objects like the Ring Nebula. Some of them look like this one. This is Messier 76 in the constellation of Perseus, and it's 2,500 light years from the Earth. These planetary nebulae can have a variety of shapes, as this little planetary shows. But check out this one. This one is called the Dumbbell Nebula. It's in the constellation of Vulpecula, and it's actually 1,360 light years from the Earth. So it's a substantial size in a small telescope. Like the supernovae, planetary nebulae also deliver many elements into our periodic table. And you may ask, well, how could all these elements be here? The Earth is made of elements that were made in stars long since gone. So how could that actually be that these elements were here in our early solar nebula when we were formed 4.6 billion years ago? Well, the answer lies in just how long-lived the universe is. It's 13.8 billion years old. And that's plenty of time for material that is spawned elsewhere to make it here from the far reaches of the universe. The universe is an amazing and vast womb for humanity. I sincerely hope you enjoyed this little foray through 8 months of the SKYTOUR livestream imagery, and hopefully this will excite you enough to join the SKYTOUR livestream, which you can find by going to the SKYTOUR livestream with Marc D'Antonio on YouTube, and take part in our live Clear Night sessions, where we explore these objects in full detail and depth. Until then, I'm Marc D'Antonio with SKYTOUR livestream, and don't forget to keep looking up and reaching for the stars. Also, make sure that you listen to SKYTOUR Radio every Sunday night starting at 9 p.m. Eastern Time on KGRA Radio at kgraradio.com.
Wish I had a kitchen with a big wooden table and a bay window looking out over the back 40 acres. I wish I had a back 40 acres full of flowers and cucumbers and a path through the woods down the hill to the river. I'll meet you there. We'll throw stones in the water. We'll throw stones in the water. Throw stones in the water. Calling on the spirits lost and forgotten, come sit around my table. We'll feast from the garden, tell stories of madness, stories of crazy and lost inhibitions, and adventures to the tops of the highest of mountains and down to the valleys, down and up again. And I'll meet you there. Stones in the water. Throw stones in the water. Throw stones in the water. Dear sweet friend, how have you been? I've been around the Did you ever get my letters? If you didn't, that's okay. I mostly wrote them down for myself anyway. I wish I had a fire with a circle full of family, your arms around my middle, so strong to hold me. Laughter and song, moonlight and stories. I'd throw words in the fire and give them to cinder all my fears and desires, cumbersome hindrance, life in the sun, life in the shadow.